Hello everyone, welcome back to Turito's live classes. So we have covered last chapter and we are come up with the next chapter, which is nothing but chemical reaction and its equation. So it's time to understand what are the learning objectives which we are going to cover in this class. So we are going to understand what is physical and chemical changes. Next is what is chemical reaction is. Then we are having examples of chemical reactions. And then if I want to understand or how chemical change is happening or how a chemical reaction is getting done. So what are those indication or observation through which I will come to know that how chemical reaction is happened. Okay. So this is going to be very interesting chapter. Okay, you can consider it as one of the most fundamental concepts in chemistry, that is chemical reaction or chemical equations. Since from this chapter onwards we are going to understand exactly what is core chemistry is, what are chemical reactions, what are chemical equations. Okay, so we are surrounded by so many chemical reactions and we do not know. Okay, this is happening, this is what is chemical change, this is what is chemical reaction is. Okay, and in chemistry we are going to put together these all reaction in the form of equation. Okay, and what these equations are, how many types of chemical reactions are there, how do we represent them, is there any certain rules to write a chemical reaction or not. So these are all like subtopics which we are going to cover, which we are going to discuss throughout this course. Okay. So let's get started. So I'll request you all to grab your notebook and pen, and whenever you are feeling okay, I'm supposed to this is something very important and I am supposed to make a note of this, that time you can note everything, be it keywords or sentences or diagram, etc. Okay. So let's get started. I have given some examples here, such as curdling of milk, rusting of iron nail, digestion of food, cutting of hair, burning paper, boiling water, folding of paper and explosion of firecrackers. Okay, so these are some few changes which we observe in our surroundings and we do not even know about it. Let's suppose I'm asking, like, you are meeting your friend after 3 to 5 months, okay, and she has cut her hair down. Okay. So can we consider it as a change? Like initially her hair was long, okay, and now she has made them short. So do we see this as a change? Of course it is a change, right? Let's suppose I'm having a paper, okay, and I'm folding that paper. So do we think like this is one of the change, like folding a paper, can this be considered as a change? Yes, it is also a small change. In our kitchen, there are so many types of changes which are happening in our kitchen also. It's a completely, we can say, house of changes which do keep happen in our kitchen itself. Let's suppose in this monsoon, okay, you are craving for a good hot cup of tea or coffee. Okay, so for making tea, what are you going to do? You're going to take some water, okay, and you are going to put some sugar or tea powder, right, and you are going to boil that water off, right. So do you know this boiling of water is also one of the types of change, right? It is. And not even that, when we keep a lid on the top of the boiled water, after a few minutes we observe that there are some droplets. This is also a change or phenomena which we have covered in our last grade, right? That was nothing but condensation. It is also a change, a phase transition is happening. Okay, so gaseous vapor particles are getting transformed into liquid particles, right? So that is also a type of a change, correct? Again, very familiar example is what? Digestion of food, the food which we have, your delicious pav bhaji, Maggi. Okay, so you are eating that food and you are not even realizing that our second home of different type of changes is nothing but our own body. There are so many chemical reactions which are happening in our body and we are not even aware of it. So our food is getting digested in our stomach, right? And it is like getting the complicated substances are getting simplified, they are getting broken down, okay, and our like nutrients are getting absorbed, right? So this is nothing but a form of change only. Okay, you are like, if I want to give very simple example, you are, if you are turning on the fan or any AC, it is also type of a change, like before and after. So whatever you are going to do, there is change before and after. If you are doing any activity, okay, before that this thing was totally different than you made it change, you made that change, okay, you change the substance. If this is happening, or be it a change, be it a substance, be it a situation, okay, consider this is a classroom, we are not having tube lights here. Now you have entered in the class and you have turned on the tube lights, you have made the change basically, right? Be it a fan, AC, tube light, okay, or you are hungry, okay, so you have cut with the knife, you have cut an apple, and there was some emergency work which you went for. But now this apple is not the way it was. It has turned some blackish, or the color has been changed. It is also type of a change. Okay, so we are always surrounded by various changes. Now various, we know that we in our lower grades we have talked about, we have studied about 2 different types of changes. Can anyone tell me what these changes are? Physical change and chemical change. Okay, so let's try to understand the examples which I have given here. Can you all tell me among these examples which one is chemical or which one is physical? Okay, let's see. Curdling of milk, what do you think? It is a chemical change or physical change? It is nothing but a chemical change. Burning of paper, what do you think? Which type of change is this? Burning of paper is also an example of a chemical change. Then we are having, next is rusting of iron nail. This is also very familiar or most commonly observed change in our day-to-day life. Okay, we have seen the articles or the objects which are made up of iron are getting rusted. Okay, the change is happening they are after some months we are able to see the flaky color on it or the brownish reddish brown color on them. Okay, so they are not the way they were, okay, when we purchased them. So the rusting had happened, and that is also type of a chemical change. Then boiling of water. Boiling of water, whether it's a chemical change or physical change, what do you all have to say on this? Yes, it has to be. Which one? A physical change, correct? Then we are having digestion of food. Digestion of food is a chemical change. Next to that, cutting of hair, definitely it's not a chemical change, right? And what are the parameters like which are going to decide whether the change is physical or chemical? We are soon gonna cover about it. So firstly, just try to classify the changes, okay? Then we are having folding of paper. I can unfold it, right? It can get reversed too. The change can get reversed. So I can say it's a physical change. Then we are having explosion of firecrackers. So it is nothing but a chemical change. Okay, so I am writing here as chemical change. So we are having different types of changes, chemical changes and physical changes. So now my question is, how we are going to differentiate between a physical and what? Chemical change. Physical change. Okay, this is what your chemical change is, right? So what are those properties which we need to understand? Okay, chemical change, very, very important, like there is a formation of new substance. There is formation of what? New substance. When curdling of milk is happen, okay, from milk we are getting new substance, that is what? Curd. Okay. digestion of food from a very complex food is getting digested into simpler ones which are having their own new composition. That's why we say new substances are generally get formed when chemical changes are happen. This is not happen in physical change. Whatever is the chemical composition that matter has, it does not change. So I can say no new substance get formed. No new substance get formed. Correct? Now again, now next point is that in a physical change, we can say mostly they are irreversible changes. We cannot undo them. Can anyone tell me from milk to curd? Okay, can we reshift the change? Can we undo them? Like, can I get my milk back from curd which I formed? No, right? So these are irreversible in nature. Mostly they are irreversible in nature. If I want to talk about physical changes, I can say yes, mostly they are what? Reversible. They are what? Reversible. There are some exceptions, okay. So such as folding of paper, I can make it back, but it won't be look like, suppose if I'm having this is what is our paper is. Now if you are going to fold it, and after unfolding definitely you are going to see some lines on it, right? You are not going to get a plain paper. So we can say it's a it is what? Irreversible. We cannot get the plain paper back, but still it is not a permanent change. That is what our next property, that chemical changes are permanent. Chemical changes are a permanent type of change, whereas physical changes are temporary. They are temporary. The fold is going to be temporary. I can unfold the paper. I can make it in square shape, the shape in which it was earlier. Though the texture will differ, but we are not going to disturb the chemical composition of paper. Okay. So these are few examples, or these are few properties. Based on this we can classify physical and chemical changes. So this is what we have covered in our lower grade. I hope this is helping you all to revise the changes which we have learnt. Okay, just quickly go through it, and if anyone wants to make a note of it, I am giving a minute, please do it quickly. Done? Let's move ahead. So these are the changes, okay, or these are the transformations from one substance to another. Maybe physical and chemical, okay, that is what we have talked about. Though we are making these changes to happen, it can be of physical type or it can be of chemical type. So chemical changes are also known as chemical reaction. Here our all focus is on chemical type of changes. Okay, we are going to in the as we all know, the name of the chapter is itself, or we are going to talk about only chemical reaction and equation in this particular class. Okay, so digestion of food, rusting of iron nail, curdling of milk, or explosion of firecrackers, right? So these are few examples of chemical changes. I have given very few examples on the board itself, but as I told you that in our home, in our body, in our surrounding, in the universe, basically there are so many changes which are happening. At this moment also there are so many changes which are happening, which we are surrounded by. Being a chemist or being a student of science, it becomes very inconvenient to observe these changes. Okay, and we cannot always write the change which is happening in the form of words or in the form of sentences. So that's how we need something called as chemical equation. We are aware with the fact that the chemical changes which we are surrounded by are nothing but chemical reaction. Okay, and these chemical reactions are supposed to note down in the form of equation. In maths also you have come across many equation, mathematical expression, mathematical equation, right? Likewise in chemistry also we need to, for our convenience, or there are so many chemicals who have got very big names, and if these so many chemicals are getting react together, they are going to give a reaction. And if I want to put this reaction on paper, it will be very hectic for us, right? It will be very inconvenient. For that, we are having a term called as chemical equation. We are going to note down the atoms, the molecules, the compounds, or the reactants. That's what we are going to learn. Okay, reactants is nothing but the chemical species who are going to get react with each other among other. Okay, so they are going to get react with each other, and that's how they are going to form new substance. That is what we have seen. Chemical changes are going to give you a substance who have got its own chemical composition, and it is different different from the reactants. Okay, so that is what is a chemical reaction or equation is all about. So let's move ahead and see what is there. Okay, so it's time to define the chemical change quickly. A change in which one substance reacts with another substance. It is a type of a change when a substance is reacting with another substance and undergoes a chemical composition, like it undergoes a change in a chemical composition. Let's suppose I am having a substance, okay, this has chemical composition like this. I am just giving in the form of symbols basically, okay, so just to make it easy for you all. And I am having substance B here, which has got chemical composition like this. And now the substance which we are getting, when A and B are reacting with each other, we are getting something new. That is what our chemical change is all about. Why are we saying it new? Because now the chemical composition of this may be look like this. It is not the way A and B were. Maybe it is a mixture of these two with new certain composition. And that's how I can say it is a C. Altogether a new substance is getting formed. So chemical change has been happened. Okay. So change in a chemical composition is very important when we study about chemical change or any chemical reaction. Got it? This is what is the key here. That's how we are, like this is what is the main property which is making physical change and chemical change different, or it's standing out from physical change basically. Okay. So let's try to understand some examples. Yeah, this is what I was talking about. So let's suppose we need to understand the formation of carbon dioxide gas. Carbon dioxide, CO2. Okay, so what is the name of it? Carbon dioxide, right? In atoms and molecules, we have studied how to write a molecular formula or chemical formula of any compound, right? So C stands for carbon, O stands for oxygen, di stands for what? Two oxygen, one carbon, two oxygens. What are they giving? They are giving a new compound, carbon dioxide. It's time to understand the same composition or the same change in the form of equation. Okay. So this is what is your carbon. Let me use the other color. Yeah. This is what? Carbon, right? This is oxygen. And now these two are giving you CO2. Here you need to understand we have taken two different substances. How? Focus here. Can you all see we have written S and we have written G. Carbon S, O2G, CO2G. So you need to understand whatever we have mentioned here. Okay. These are basically states of the substance, of an atom, of a molecule. See, carbon is present in solid state. It is reacting with oxygen, which is nothing but a gas. Reacting, here we need to understand. We are having what? Symbol plus. That is showing us that, okay, carbon and oxygen are reacting. Addition sign shows that these two substances are reacting with each other. Okay, and here we are having arrow sign, that is saying like carbon and oxygen are reacting together to yield what? CO2. Okay, so we are now having carbon dioxide which is in gaseous state, which has its own set of properties. Okay, carbon solid has its own property, oxygen as a gas, it has its own property, and when these two get combined with each other, we get CO2, carbon dioxide, which is all a new substance altogether with its new composition. Got it? So that is nothing but a chemical change. This is nothing but a chemical reaction. Whatever we have written here is nothing but a chemical reaction. Chemicals have reacted with each other to give you products. Reactants, these are reactants. The substances who show tendency to react with each other are reactants. And with reaction or on reaction, they are going to give you something new. That is what we called as products. Followed? We are going to understand about equation and the rules to write chemical equation further. But as of now, are you all clear with the idea of chemical change and chemical reaction? Great. Make a note of this, like you can write this equation and what this reaction is interpreted, like what it says, what it indicates. You can quickly make a note of this. Done? Okay, let's move ahead. Give me a second. Okay, so here we are having next example. Here we are understanding the formation of water. So we are having hydrogen and oxygen. See, hydrogen, it's in gaseous state, right? And that's why the symbol is G. Whereas oxygen is also in the gaseous state. Okay, they are reacting with each other. Two parts of hydrogen gas are reacting with one part of, okay, it's one part of oxygen to give two parts of H2O molecule, which is a liquid. Correct? Now, H2O has its own set of properties. Okay, that's why the chemical changes happen. Why? Hydrogen, it's quite combustible, like it undergoes combustion, whereas your oxygen is what? Supporter of combustion. Supporter of combustion, whereas it's what? Combustible. Hydrogen is combustible, it is supporter of combustion. But when these two different substances, reactants, are reacting with each other, they are giving you water, which is also in state liquid. Unlike these two, they are in gaseous state. Okay, so state wise, water molecule is different, and property wise also, it neither combustible nor supporter of combustion, right? In fact, it extinguishes the fire. Extinguishes the fire. And that's what I'm talking about continuously. It has its own property which is not like the reactants. So here a reactant, that is what R1, that is reactant number 1, has its own set of property. Oxygen, that is your reactant number 2, has its own set of property. When these R1 and R2 are getting reacted with each other, they are giving you product. Let's suppose we are having a product, water. It has its own set of property, and that is what is chemical change, that is what is chemical reaction, and this is your chemical equation. Okay, follow till here. Is there any confusion? Is there any doubt so far? So we have just started with physical and chemical changes, and we have gone through the definition of chemical changes or the properties of chemical changes, and we have studied few examples of a chemical change, chemical reactions. Okay, follow till here. Shall we move ahead? All right. Now moving ahead, let's try to understand some examples of chemical changes or chemical reaction. We are having burning of wood. So it is nothing but a chemical reaction. It is nothing but a chemical change. How? When like wood is getting burned out, okay, wood is getting burned out, what happens? We get some water vapors, right? There is a formation of water vapors. Plus one gas is getting released, that is what, CO2, right? And we are getting some form of energy, heat energy, sound energy, light energy. Okay, so generally this is what happens when burning of wood is taking place. This is a chemical reaction, or this is nothing but chemical change which we observe in our daily life. Do you all agree with this? Yes. Moving ahead, digestion process. Okay, so when we are having food, okay, and through buccal cavity it's going in esophagus, through that it is going into intestine. Okay, so we have seen the biological process here about digestion. Okay, so basically what's the idea here? Just complex or complicated molecules which are present in the food are getting divided into the simpler ones, and that's how the simpler molecules are not like they are unlike when it comes to properties with the complicated food which we have already eaten. Okay, tell me if we are having egg. Okay, egg is nothing but source of protein. Now this egg is getting digested in our stomach. So basically protein has the amino acid. Okay, so amino acid, like from the protein we are going to break down these amino acids. So is it possible practically to collect with the amino acids and get back to the egg which we ate? No, right? And the chemical composition varies basically. So here digestion of food is also one of the examples of chemical reaction which is happening in our body. Okay, even respiration is one of those examples, right? So these are few examples of chemical reaction. Moving ahead, yes, photosynthesis. In plants also we have seen some chemical changes. See what happens in the presence of sunlight. Plants generally, like with the help of carbon dioxide and water, they give, like they utilize these two essential things, and they are going to give sugar and oxygen molecule as a product. So how do we write it? So let's suppose if I want to write a chemical reaction, I can write in 6 CO2 plus 6 H2O in the presence of what? Sunlight. When it is happening? When we are having what? Sunlight. In the presence of sunlight. What are we getting? What are the products? So what these two things are giving us? Carbon dioxide and water. They are giving what? C6H12O6 plus there is different thing, that is what? Oxygen 6O2, right? This is what is nothing but a sugar, and this is your oxygen. So basically if I want to elaborate this, this part is nothing but what? Reactants. Okay, and these are all the products. Okay, follow till here. So these are two different reactants, carbon dioxide and water, that combining together and in the presence of sunlight. They are giving glucose and what? Oxygen. So this is also very, very fundamental and important chemical reaction. Got it? Let's move ahead. Then we are having curdling of milk. The milk which you like to have with your aloo paratha. Okay, so it has undergone already a chemical change. So we are having milk basically. This is what is milk. You must have seen mother has like she makes, like she is the one who does the change. Actually she is not. There are some chemical changes which are taking place inside the milk, and because of that milk is getting converted into curd. She is just helping to make this chemical change get done. Okay. So what happens when we are having like milk and like this transformation from milk to curd? Exactly what is the chemical process happens? So we know that milk has lactose type of sugar which milk has. Okay. And in this lactose actually we are going to add have you seen how mother does this? She keep like we allow the milk to boil, then we we are going to cool it down, and like it's not, we are not going to make it completely cold, but in warm milk we are going to add some precursor curd. Okay. So this is nothing but a curd. We are going to take 2-3 spoons of curd, that is what we called as precursor curd. We are going to add it in the milk which we have taken, which we have boiled, right? So it has lactose. So precursor curd has lactobacillus. This is nothing but a bacteria. Now you all must be wondering, ma'am, this is bacteria, it is very harmful for us. No, there are two types of bacteria, right? Positive and negative. It is one of the positive bacteria. Okay. So what this helps, or it goes or it reacts with the lactose which is present in the milk. Okay. And it actually gets multiply. Okay. The multiplication happens in the milk with the help of lactose sugar. And then we observe something like this. So your lactose is getting converted into lactic acid. Okay. Now this lactic acid is going to denature, or it is going to change the arrangement of the protein which is present in milk. Which protein it has? It has a protein named as or known as casein. So milk has whey protein and casein. Okay. So now the lactic acid which we have obtained when lactose and lactobacillus bacteria are getting reacted, they are going to give lactic acid. This lactic acid is going to change the structural arrangement of the protein which is present in the milk. Okay, so which protein is that? Casein. Okay, so what that arrangement is? Okay, casein has if I want to write it here, it has tertiary and quaternary structure. Okay. Structures, or you can understand it has a very complicated structure, but with the help of lactic acid, casein structures are going to get simplified. So they are going to get into primary structure. They are going to get transformed or changed into primary structure. Casein has this complicated structure, is now getting transformed into, or it is going to simplified into primary structure with the help of lactic acid. From where we have obtained the lactic acid? From lactose and lactobacillus bacteria. They have turned lactose into lactic acid. This lactic acid is going to denature, it is going to destroy, or it is going to change the structure which is present in the casein. And this primary structure, after observation, we say that it is nothing but what? A semi-solid substance. Let me write it here. Semi-solid. And that semi-solid substance is what our curd is. So see, the chain is very long, the chemical chain is very long, and that's how we say it's a chemical chain. That's how we say it's a chemical reaction which is followed by these many substances altogether. So do you all agree that curdling of a milk is a chemical change? It is nothing but a chemical reaction which we do not know, but it happens naturally. And then this very delicious curd we enjoy with our food, right? From milk. So I am asking you again, is it possible to convert this curd into milk? Will it get reversed? Absolutely not. That's why it is a chemical reaction. Got it? Is there any doubt? Is there any confusion? I'll just revise the curdling of milk so that you will get better idea once again. So we are having boiled milk, okay. It has sugar called as lactose, right? And in this milk we have added precursor curd which has lactobacillus bacteria. Now when lactose and this bacteria are reacting together, basically from lactose to lactic acid gets generated, gets formed. This lactic acid now going into milk, and it is going to denature, it is going to change the structural arrangement which is present in milk or protein of milk. So basically it has some complicated structures. Tertiary and primary structures are getting turned into primary structure. Tertiary and quaternary structures are getting turned into primary structure, and this is how we are going to get something the nature of it is quite semi-solid, thick, and quite liquid will be there, semi-liquid, semi-solid kind of substance will get generated overnight or after 4 to 5 5 to 6 hours. That is what our curd is. Got it? Is there any confusion? So henceforth, do not say curd is a curdling of milk is a chemical reaction. Also tell, if someone asks you how this happens, you should know about this, right? It's a very basic science. Now I hope you all are familiar with the process of curdling of milk. Correct? Alright, then quickly make a note of this chain so that you will, it will be helpful for you after class to revise it quickly. Done? Okay, then let's move ahead. Rusting of iron. So this is what again most commonly observed type of chemical reaction or chemical change. We know that these, let's suppose these are all iron articles, and they are getting iron when it is getting surrounded by what? Oxygen and what? Certain amount of water. It is going to give you ferric oxide. You all must have seen. Okay, so we can say iron oxide is nothing but a rust. Okay, the substance is no longer remain the same. Okay, if I am I'm purchasing iron, like suppose I am having iron table. Okay, and after 6 months or so, I am observing something like this. Can you all see? Can you all observe? Haven't you seen it before? Okay, so if this transformation color wise is happening, it shows us that okay, something has gone wrong or something had happened. What had happened? A reaction, a chemical reaction, a slow chemical reaction had happened, and that is nothing but also rusting of iron. Okay, moving ahead. Yes, now it's time to understand or to revise whatever we have talked or understood so far. So I told you about chemical equation. It's nothing but a equation where we are going to keep all the chemicals together in very simple words, if I want to say it. Okay. So it's nothing but a schematic representation of chemical reaction. We are not going to write every time. Let's suppose I am saying carbon is reacting with oxygen to give carbon dioxide. This is what is a sentence, this is what is a chemical reaction. But what if I am writing something like this very quickly? Isn't it very easy to write? This is what is our chemical equation, this is what is our chemical reaction. A schematic representation. We are not going to write the complete sentences, not even words. We are going to use chemical equation. Okay. So here the symbols and formulae of different species are used which are involved in the reaction. Exactly, that's what we have done. So instead of carbon, okay, I did not even write the complete word. What I did, I just wrote only C, which is nothing but symbol for carbon. Then reacting with oxygen gas. I know oxygen gas, it has to be O2, correct? And giving you carbon dioxide, CO2. And that is how I have written the formula of it, CO2. Reactants are written on the left hand side of reaction. Okay, here that's what is we need to understand. Can you all focus here? Can you all just pay attention here? Carbon dioxide is getting formed on the other side of the reaction. But what about here? Like what's happening here? So this is what is your left hand side of the reaction, right? So these are all like carbon and oxygen. These are two reactants. What we refer them as reactants on LHS. Okay. So always and always try to remember reactants are always going to reside on the left hand side of any chemical equation. Got it? Moving ahead. We know that the other side we are having what? Like this is the right hand side of the reaction and these are nothing but products, right? So on left hand side we are having reactants, on right hand side we are having products. Okay, so that's how a chemical reaction looks like. Again, there is one very important thing which I already talked about, plus sign used in case of two or more reactants when they are going to react and giving you product. So here we have used plus sign. Okay. So that shows that carbon and oxygen both are reacting with each other to give you carbon dioxide, right? And again this arrow is showing that to give, or I can say to yield, to produce basically. What? Product. What is the product here? CO2. So carbon and oxygen are reacting with each other and now they are going to give carbon dioxide. Is it okay? Is there any like a problem to follow till here? Great. Let's move ahead. So yeah, this is what is a general representation, reactants giving you products. So R stands for reactant, P stands for products, and there are chances that you are going to have so many reactants who are going to react with each other to give either one product or many other products, and these are nothing but byproducts. This first one will be major product, okay. This will be a major product, and P2, P3, P4 they can be called as what? Minor products. Got it? Great. Okay, so till here Is there any confusion? Is there any doubt? We have talked about physical and chemical changes. Then we have seen what are the parameters or the properties of chemical changes. These changes are nothing but chemical reactions, and we have seen some rules to write any chemical equation. So that was all about today. Is there any confusion? Is there any doubt from your end? Just like type your doubts in the chat box so that I can solve them quickly. Okay. Okay students, then that was all for the day. Soon we will meet in the next class with the in continuation of this chapter. Till then, bye, take care.